Okay, so let us start with uh, polymorphism, method overloading, overriding. Okay, so now what is method overloading? Method overloading is compile time polymorphism. Compile time and runtime, they are different. Compile time means when the coding is getting converted to machine level language by the by JDK, by Java compiler. So when it is getting compiled, at that time method binding occurs, like what method is going to be called, and everything is resolved at compile time. Before that, before the concept of compile time or runtime, let me first explain how methods look like when we talk about overloading. This, I have got a class here. Okay, I have got a Java file here, say OverloadDemo.java. Say the name of this class file is OverloadDemo.java. This is the name of the file with which we save in the bin folder. Now in this file there are two classes. One is class A, MethodOverloadDemo. One is class B. The main method is in B. As you can see, the main method is in B, class B, and in class A there are two methods with the same name. Okay, like in my previous videos I had been talking about overloading, like having two contacts with the same name but different properties, like other ID address, one of the contact having other ID address, the other contact having other ID, PAN card ID, bank name. I told you, I had been explaining overloading in the previous videos. I'm elaborating on it here. Let us take the name to be area of the methods, two methods with the same name, same return type, but different set of parameters. Float parameters. The first method has two parameters, each of whose data types are float. That is, they will be able to take decimal numbers, decimal integers. And this one has got only one parameter. These two data types can be different, like we can have an int and a float, like int a and float b we can have, or a string s, float b also we can have. And the return type can also be different. We can have this method returning integer and this method returning a float. So this is what the signature is different. This is the set of parameters, it is different. Only the name is same of the two methods in the same class. This is overloading. How they are accessed? I am now going to access the methods from the main method. I create an object of this class in which the two methods are residing. AMethodOverloadDemo is the name of the class, so I create an object of that class, aobj. a method overload demo aobj equal to new a method overload demo. Now this aobj has got referred to some memory space, memory allocated memory, wherein we can store data variables. Now with this object, with the object of this class, I call the methods of this class. Okay, and I have directly written in the System.out.println. We can write like this instead of taking it in two separate statements. Like we could have simply called this and collected the value in a float variable, and we could have printed in the next line. But together two lines have been combined like this. Syntactically this is perfect, correct. Saves your line of code. Saves your line of code. For understanding, I am separating the two lines. So you see how I separated? These are the two lines that have been combined like this. This part, this if, has been assigned to this, right? F variable of type float, data type float. So instead of f, I can simply put this. This is the same thing. And then, so now I am calling the method with two sets of parameters, right? In one method there are two parameters, in the second line there is one parameter. So according to the number of parameters, the method will get called. In the first line, when we are calling the area for the first time, calling the method area, this one is invoked, this one is called. The transfer is the control is transferred here, because there are two parameters here, there are two arguments sent. One more thing I would like to say, the values we pass here while invoking are called arguments, and these with the variable name with data type are parameters, where we are defining the method. These are parameters, these are arguments. Arguments get assigned to parameters automatically when we call that method. So the two values are passed here and we are returning the value here. Again we can collect this in a float type variable and return that f, like float f equal to a asterisk b, return f. Instead of that we can simply return a asterisk b, and it is getting printed here, 4.5 into 6.5. Then the second time when we are passing 6.5, this one is getting invoked and a into a, 6.5 into 6.5 is returned and printed here. So this is what is method overloading. And with this comes the compile time polymorphism. Everything is happening here compile time, that is when we are passing arguments, which method is going to be called, that is decided at compile time, which is why it is static memory allocation. Static, it is not dynamic, it is static, fixed. Versus method overriding, which is this, which is runtime. Method overriding is runtime polymorphism. So method overriding, let me talk about it before explaining runtime polymorphism. So how does a method overloading looks like? Here we have got a class, again say we have got method, we have got a Java file OverriddeDemo.java. In this Java file there are two methods, BMethodOverrideDemo and B. Here BMethodOverrideDemo has got a method void display, a display method whose return type is void. It is not returning anything, it is simply displaying a message, hello Ritu, on the screen. The System.out.println. In the class B, where we have got, there are three classes, class B method override demo, class B, and class C. C is where the main method is there. So execution starts from here and control is passed to here, then control is passed to here, like that. So in the class B, class B extends B method override. Class B extends this class. So this becomes the base class, the parent class, and this B becomes the subclass, the child class. So extends, with the extends keyword, we are inheriting B method override demos, properties, methods, data, methods, everything. So herein comes the concept of inheritance. Inheritance related, that is an important concept of object-oriented programming. So B extends this class, and class B also has got a method display with the same return type, same name, and same set of parameters. No parameters here, but overriding, with overriding we have got the signature and the name both are same, as opposed to overloading where only name is same. In overriding, signature, that is the number of parameters, the data type of the parameters. If say there were an int I here, there also has to be an int I. Supposedly there are two parameters here, float x, int y. We need to have float x, int I. So that is the signature and the return type also. Everything needs to be just the same. And here we have got different utility. We are printing a different statement here. So now comes to class C. Now from execution point, this is the execution point. I had been explaining like this, but from terms of execution, the entry point is here, void main, control comes here, void main, then moves on to the next line, bobj equal to new b, wherein an object of class b is being created. Bobj is the object of this class. New b creates the object, and that gets assigned here. We are assigning it to a name. Actually, this portion, this much is perfectly syntactically correct. New b, a new object is created. New b, memory is allocated. But how do we access the memory? We need something to point to that memory location. So wherein we require a variable, we require a name. So this, we give a name here that is referring to that memory space. So we create an object, and through this object bobj.display we call the method. Now this display, since we have created object of class b and we are calling the method of class b here, so the control plus is here, and here this thing gets printed. How are you doing? It gets displayed on the screen, and then it terminates. It does not go here. Now how do we print this statement also? After this, it is possible that we create an object of BMethodOverrideDemo here and get it displayed. That BMethodOverrideDemo b equal to new b and another memory space referred by b, and then b.display, supposedly b.display, or BMethodOverrideDemo override object equal to new BMethodOverrideDemo override object dot display, and this will get displayed. That is one way. But we can use the super keyword to invoke the method of the base class, parent class. Here we write super dot display, and this method gets called. So first this is printed, then this is printed. First hello Ritu is printed, then how are you doing is printed, displayed on screen. So super is a keyword to invoke the base or the parent class's method from the child class's method. Super has got other utilities also. We will cover that in subsequent videos, but in this one, this is what the utility is restricted to in the concept of overriding. That super will be, if we use the super.display, means the super class's display method gets invoked. That is how we print both the statements. And then the control, after displaying this how are you doing, control comes here. So how the execution flow is from here to here to here, then back here, then here, and terminated. So this is the concept of method overriding, and this is runtime because all memory allocation, memory binding, everything occurs at runtime, that which method is going to be invoked based on the parameters. Everything is runtime, not compile time. Which method to be invoked, the execution flow, everything is determined runtime. Everything is resolved runtime, which is why uh, it endorses the uh, uh, concept of runtime polymorphism. We call method overriding as runtime polymorphism, dynamic binding, dynamic memory binding, and dynamic memory allocation, and runtime polymorphism. Polymorphism, as you know, the same name but different uh, the same thing that has different utilities. That is the notion, that is the idea behind it. So this was an important concept. I hope this video has been very educative. Do share it and like it. Take care. Subscribe to my channel. Bye. Bye bye.